Broadcast is now starting. All attendees are in listen-only mode.
All right, everyone, thank you for joining our webinar today on this exciting topic. Before Heather jumps into her presentation, just wanted to go over a few housekeeping items that we have. If you have any questions, please make sure to ask them in the question window of GoToWebinar, and we will make sure to answer them. And if you have other questions that we weren't able to answer, head over to the Trailblazer Community at trailblazer.salesforce.com. Today we have joining us Heather Dykstra, our Senior Developer Evangelist, who has been with us for some time and is super awesome and amazing, and has done some really great things on our team. And I'm sure we'll also share a little bit about what she'll be up to at TDX this year. So if any of you are coming to that, we'd love to hear about what you're up to there, Heather. Also, if you want to reach her, this is her email address and her Twitter handle, which she'll go over again. Most of you have seen this, our forward-looking statement. Just a reminder to please make all purchasing decisions based on products that are already generally available. And if you have any questions or you want to go social with some of your questions, these are all of our handles. We're on Twitter and we're on Facebook, we're on LinkedIn and on YouTube. Also, this webinar is being recorded and will be posted to YouTube. So check out Salesforce Devs on YouTube. And with that, I will hand it over to Heather.
Awesome. Thank you so much, Nisha. So as Nisha said, I am Heather Dykstra. I'm a Senior Developer Evangelist here at Salesforce. You can find me on Twitter, most likely, at Heather L. Dykstra, and then also via my email there. To give you a little bit of an insight on what I'm doing for Trailhead DX, since Nisha asked that I shared that with all of you, I'm working on a large robotics demo that I'm very excited about, and it actually leverages a lot of Apex, which is why I'm super excited today to talk to all of you about a brief introduction to Apex, which is our programming model that we use on the Salesforce platform. So let's dive in, assuming I can press the next button on my slide. You know, technical issues, it's fine. Here we are. All right, so what we're going to talk about today is we are going to cover the fundamentals of what it means to work with Apex and also the Salesforce platform, because we recognize that some of you may be completely new to Salesforce and what we actually would want to be doing with that platform. We're also then going to dive into a couple of code samples so that I can show you how you're going to use the different types of Apex artifacts to write the code that you need to write to actually solve the business problems that you're trying to solve. And then, because no presentation on code is complete without testing, we're going to talk about how we actually test Apex code. Cool. So let's start with the fundamentals. What is the Salesforce platform and what is the Apex language? Well, it all starts with the Salesforce platform empowering businesses and IT to work together. And so what the Salesforce platform allows you to do is to use declarative and programmatic tools to solve real-world problems every single day in your business. Now, it's really hard to measure, but we estimate that about 80% of what you would want to do on the Salesforce platform, you can do with our declarative drag and drop configure tools through the setup UI. Now, again, really hard to measure. That's not a solid figure that you should go by for every project. Some are going to vary, but that's pretty standard. Of course, those declarative tools aren't going to do everything we want. So we're also going to have to use our programmatic tools about 20% of the time. And these are the code tools like Apex, which we're going to talk about today. So what is Apex? I've said this word a couple of times already, and you're probably like, Heather, you're crazy. What are you talking about? Well, it's really an object-oriented programming language on our platform. It's very, very similar to a couple of other languages that you may have worked with before. So if you were a C# developer or a Java developer before you came to the Salesforce platform, you're going to feel right at home with Apex because it's very similar with the class structure and the way that we call through to different sorts of API versions. The cool thing about Apex, though, is that it's specific to Salesforce. So it gives us some specific annotations and interfaces that allow us to actually access a first-party access to the data layer, allowing us to really get at all of the data in our Salesforce instance. It's also API versioned, which means that I can write code today on the API version that we currently have released, and it will still work next year, and it will still be based on the current API version that I wrote it at this year. So that's really nice. And finally, and probably most importantly, and the coolest part about Apex, is that it's cloud-based, which means that all of our compiling, our debugging, and our testing actually happens up in the cloud. And you don't have to worry about having a bunch of different tools installed onto your computer to make sure that you can actually write this code. You can all do it through the developer console. Now, of course, with any good programming language, you're going to have limits. And in our case on Salesforce, because we work in the cloud, we have this thing called governor limits. And these actually help you to be a better developer. They are used by Salesforce to express the limits of our underlying multi-tenant system. Basically, what that means is that all of our customers share the same system for all of the code that they're running every single day. And so in order to make sure that it's fair and equal for everybody to have the same access to the resources that we're providing, we have these governor limits that are the same for all of our customers. These are limits that are specific to certain types of operations, such as running a SOQL or SOSL query, which we're not going to cover today, but if you're running a query, we have limits on that. And we also just have general limits on how many times we're going to send out an email or make a mobile push call. So you just have to be aware of that when you're writing this. But the cool thing is that these are only per transaction. So it's actually really easy to make sure that you're writing good code that follows these governor limits. Now, this is a pretty complicated topic, and this is all I'm going to say on it for today, but you can definitely dive in more a little bit later. So why would I use this Apex if you said that I can do 80% of my work with the setup UI? Well, here are a couple of really great use cases that we're going to briefly talk about today. You can write UI controllers so that you can better access the data that you might need to for other types of code on the front end. You can also write event triggers. You can create custom REST or SOAP API endpoints. This is a pretty favorite feature of mine, as I do this quite often when I'm programming robotics and integrating them with Salesforce. You can also use Apex to do batch processing and scheduled logic. So Apex adds all of this control and flexibility, and there are clearly a lot of great use cases for what we can do with it, but we have to remember that before we can actually start to do that. Of course, the lovely thing that one of my colleagues loves to tell me all the time is that code you don't have to write is code you don't have to maintain. And that's why we really advocate for you leveraging both the clicks and the code side of the platform. It's not an or, it's an and. They work together really well and they make you more powerful. So let's dive into some code samples, because that's what I'm itching to show you. So we have some core Apex artifacts that define how we interface with Apex when we're writing code. The first is a class. This is pretty standard and what you would expect if you come from another object-oriented language, especially something like Java. This is going to feel really normal to you. We've got our public class, and we've got the name of our class here, awesome merchant service. This is pretty standard. The second kind of Apex artifact is something that is probably going to be new to everyone on this call, and it's called a trigger. In this case, our trigger is going to be called awesome trigger, and it's on our merchandise object, which is notated here as merchandise __C, meaning it's our custom object. And we're going to run this trigger after we insert our data onto this object. This trigger is something pretty different, and I'm going to tell you a little bit more about what it is in a few slides, but I just want you to understand that there are two different Apex artifacts, and this is the notation that you would use to start either of those. So let's dive in now to classes. I have an Apex class here, and this is a pretty simple class. It's called Warehouse Data Install. And just like any class in most modern programming languages, I can instantiate it, and I have my initial method here, warehouse data install, where I could actually put in things like parameters or anything else that I would want to know when I instantiate an instance of this class. And I would want to do this if I'm going to call it in another class or in a trigger. I also have two functions here. I have a function called hasData that's going to make sure that I actually have data in my merchandise object by running a quick and simple query here. And then I also have a function that creates some data. Now, the reason that we have this create data function is so that we can actually test our hasData function. Our create data function isn't going to provide us any business use case right now. It's really just there to test our hasData function. And when we get into testing, you'll see that come full circle. So I just wanted to highlight that now. So that's what classes are. They're pretty cool. They're pretty standard to what you would expect from a class, but I mentioned that triggers are pretty different. So what's a trigger? Well, it's Apex code that's executed before or after a database operation. This is different than process builder or flow, where process builder and flow have to happen after database operations. Triggers have a lot more that they can do because they can do something before the database operation, and they can also do things based off of a delete or an undelete of data. So they give you a lot more flexibility in the times that you're allowed to trigger them and actually have them impact your data. Typically, if you're using a before trigger, you're trying to validate or modify values before they're saved to a database. And if you're using an after trigger, you're trying to act on confirmed data and access new record values. So that's pretty much what a trigger is in a really fast sense. But to hopefully give you a little bit of a better idea, let's look at the code behind this. So this is a really basic example of an Apex trigger. I've got a trigger here called myTrigger, not the best name, I'm sorry. And it's triggering on the account object. And it's doing this before data is inserted. So this is a really great use case for a trigger because if you'll recall, I actually can't use a before insert in flow or process builder. So we already know that we're writing really good code here. And then we'll have a method here that says for every account, run this trigger and do something new with our new accounts. Now, I don't have all the code here and all the logic for what's going to happen to all of those new accounts, but I've set up my framework here for working with this trigger. The other thing to highlight is that our for loop here actually executes on batches of up to 200 records. So we're following our trigger best practices of making sure that all of our code can handle whether or not it's one record or a lot of records that are hitting the system that need to run this trigger. So I mentioned some of the best practices as we were looking at the example code, but I want to just dive in a little bit more because there are some amazing design patterns that we use here at Salesforce that we advocate for all of you to adopt when you start learning triggers. The first is that you should have one trigger per S object type. And when we say S object, that means Salesforce object. So something like account, or earlier you saw my merchandise custom object. That was also considered an S object. So I wouldn't want to have 3 triggers for account. I would want to have 1. And that's because if I have 3 triggers for account and then I'm also using a flow and maybe a validation rule, it can get very complicated to keep track of what's happening when. But if we limit the amount of triggers to just 1 per S object, we're going to have a lot easier time reading and understanding what's happening in our code as we execute it. The next best practice is to make sure that our triggers process multiple records at a time. In other words, we typically call this bulkifying our trigger. And that's what we were doing in our previous slide when we looked at the example code. We were able to handle up to 200 records at a time there. Now, of course, we want to be able to handle even more than that. So as we continue to write out our logic, we're just going to be aware of the fact that we need to make sure that we're writing all of these triggers to process all of those records. There's a lot more information on this. If you just simply Google how to bulkify my trigger, there's lots of people that can help you make sure that you're writing this the right way. The final trigger best practice is to move our logic to a helper or handler class. This is something that we usually call a trigger handler. And this is so that it's easier to test all of the code happening in your Apex trigger. Because as we dive into Apex testing, what you'll see is that we test Apex classes, we don't test Apex triggers. So if you move all of your logic to a class and then you call it from your trigger, not only does it keep your trigger clean and make all of those functions reusable across many triggers if need be, but we're also going to move it to a class so that it's testable. So this is really like if there's any one thing you take away from today, you should take away that when you write a trigger, you have to write a proper handler class to go along with it that contains most of the processing logic for that trigger. Okay, so that's our basic overview of Apex classes and Apex triggers. I know we went through it really fast, but I've only got about 5 minutes left, and I don't want to forget to tell you all about Apex testing and how we can make sure that we're implementing our most robust code. So let's dive in. A brief overview here is that we actually have a built-in testing framework for Apex that will help us test our Apex classes. It's helpful if you write your tests as you write your business logic code because you have to have 75% code coverage to deploy your code from a sandbox to production. This is really important that we actually have this code coverage because not only do we use it to make sure that you can deploy your code to your org, but we also use it when we do our releases to make sure that your code still works. So before we push out a release to you, we run these tests that you write on your org to make sure that our new updates aren't going to negatively impact you. So Apex testing is important because it helps you, and it's important because it also makes you future-proof. So how do we write an Apex test? Well, that's a great question. It's pretty similar to how we actually write an Apex class, with one major difference. We annotate the class and every method with this @isTest annotation. And that's telling our compiler that, hey, this is actually a test method, and it's going to use all of the code that we're trying to test to properly test. So you can see here we've got a couple of different functions. We're making sure that our hasData function that we wrote back when we were looking at our classes actually works when there's no record, there's no data available. So we're going to make sure that we use this system.assert_equals function to check whether or not our hasData function is properly returning false. And this is the same basic pattern that we're going to follow for the rest of our tests. And you can see here, like I mentioned before when we were looking at our our old method that was creating a bunch of data called createData. If we look down in method 3 here, the createData_works test function, we can see that we start our test with test start test, and then we call our warehouse data install class .createData. So we're going to create some data. Then we stop our test and properly assert that we actually have more than 0 merchandise records. Now, there's a lot of different syntax that's happening here. We've got system.assert_equals, we've got test.startTest and test.stopTest, and then we've got our isTest annotation. All of these things are key to making sure that our tests are working accurately and that they're testing things like our limits. Now, again, this is a really brief overview. I just wanted to show you the syntax here and start to explain to you what's happening, but there's so much more that you can learn. So before we let you go, I want to tell you about some best practices. When we're writing our test code, it's just like writing test code with any other language. you want to make sure that you're following most standard protocols in generating your own test data, writing both positive and negative test cases, testing with many records at the same time, and then specific to Salesforce, that you actually exercise our governor limits and make sure that your code is always operating within those limits. And then that you're also testing different user configurations. So if you're like me and you write code in an org that you happen to be an admin in, sometimes it's easy to forget that when you push this code, it might be actually accessed by a sales user. And maybe you didn't test that. And so you want to make sure that you are actually testing for different user configurations with roles, profiles, and permission sets before you deploy your code to production. So that is all of the content that I have for you today. I know we ran through so much in such a little amount of time, but I want to encourage you all to make Trailhead your next step. Trailhead is the fun way to learn, and it's really easy to get started with Salesforce development today, but actually going and earning the Apex Basics and Database badge. Now, we'll have a link for you at the end of the webinar so that you can just go straight to this. But it's super helpful. It walks through a lot of what we just talked about and a little bit about how we can do queries. But if you finish that and you're like, oh, I want to learn even more, you can stay on Trailhead. There's lots more trails and different modules that will walk you through how to do proper Apex testing, more complex Apex, and also how to write triggers and do all of the basics there. So that's awesome. And I just want to say thank you so much to everybody who's on the call and for listening to me today. I hope you learned something new about Apex. And I think I'm going to switch back to Nisha and we're going to do a little bit of Q&A.
Yep, let's get started. And also to everybody on the call, I just added a link to that Trailhead module that, that Heather was talking about. All right, so we have a question from Nitin. His question is about how to write a test class for catch blocks, specifically for the exception line.
That's going to be really complicated for me to try and explain to you through this webinar. So go ahead and reach out to me on my email or on Twitter, and I would be happy to actually just give you that example code. There's a couple different ways you can do it. You could also go to the Trailblazer community and actually have them posting code examples there. But I'd be happy to properly answer that question for you via email or Twitter.
Great. Heather, how long is a given API version supported?
So as far as I know, forever. I think there are a few exceptions to that rule, and we're really clear about when an API version is no longer allowed. But if you're writing something in an old API version, just know that you're not taking advantage of the new features of Apex, but it should still work.
Great. What do you mean when you talk about bulkifying code?
Yeah, so I mentioned this a little bit earlier. Bulkifying code basically just means that we're writing our code to handle a lot of different records. And when I say a lot, I don't mean 10 or 100, I mean like 1,000 or 2,000. And I know that that's odd because you're thinking, but my use case is when a user goes and does this one thing one time, except for that you never know when you're going to have a bulk data load or when there's going to be a bunch of users doing that at the same time. And so you really want to be prepared for that circumstance. And that's what we mean when we say bulkify your data or bulkify your Apex, is that we mean you write Apex that's going to be able to handle a lot of records.
Great answer. Thanks, Heather. How do I put a breakpoint in Apex code?
Oh, so we didn't really talk about the tools that you can use to write Apex. There are a couple of different ways that you can currently do this. The number one most recommended way right now is actually to download and install Visual Studio Code and the Salesforce extension pack. And the reason that I'm highlighting this is if you do that, then you get this really snazzy feature called the Apex Replay Debugger that allows you to set breakpoints and step through your code as long as you have a debug log from your system. And that's the easiest way to set breakpoints in Apex code. There are a couple of other ways. There are some paid tools, but my recommended way would be to download Visual Studio Code and the Salesforce extension pack, and then get started with the Apex Replay Debugger.
Cool. How about linking GitHub version control to Apex?
Oh, sorry about that. So we didn't talk too much about version control in this, but basically, if you're writing Apex, you can save that up to version control using a myriad of our different tools, whether you're using our ANTS tools or our Salesforce DX tools to pull down all of the data from Salesforce. Just remember that because you're working on Salesforce, you're developing up in the cloud. And so if you want to actually be able to push that code to some source control like GitHub, you're going to want to go ahead and pull that down from the cloud and then push it up to the source control. And so again, the recommended way to do that is to install the Salesforce DX extensions and Visual Studio Code to pull down that code. And then you can use the other extensions there to push to Git or to your preferred source control.
Great. Is there a resource I can use to study Apex syntax?
Yeah, so Trailhead is a great first step to start to understand Apex syntax. And if that's not enough and you really want to dive in even further, if you go to developer.salesforce.com, there's tons of resources there where you can, again, view all of our documentation on Apex and the other types of code that you can write on the Salesforce platform.
Great. And what tools, and I think you covered some of this, but what tools can be used to write Apex?
So really, you can use the developer console. You can use any modern IDE that supports working with Salesforce, whether that's IntelliJ or Visual Studio Code or Cloud9. I know there are a couple of options. Any of those are going to work for you to get started with Apex.
Is there a way an admin can test in a sandbox whether Apex in a change set will pass validation in production? How can I make sure that I have all of the related components, or to check if a developer forgot to include something in the change set?
Oh, okay. This is a little bit complicated. Let me just take a second to read through it again. So it depends on the code that they've written and how you're testing your change set. Theoretically, you should be able to test that in a sandbox and do a sandbox to sandbox deployment to make sure that you're getting that validation of having everything. I think for a more precise and in-depth answer, I would recommend that you reach out to me or to the Trailblazer community to help you solve the problem that I think you're trying to solve.
And I think we have time for one last question, and that is, should I have prior programming experience before I try to dive in learning Apex?
No, I don't think so at all. I think it helps a little bit in the beginning because there is a little bit of a curve to what am I looking at and how do I do this? But if you start with Trailhead and you take those online resources seriously, you can totally get started with Apex and all the other programming languages on the platform today.
Awesome. Thank you so much for this important information, Heather, on Apex. I think it's been really helpful. Just as a reminder to everyone on the call, you can access this video on YouTube at youtube.com/Salesforce developers. We also have a ton of other video content there as well. So if you are getting started, that is a great place to go to learn. Also, if you have other specific questions that we were unable to answer today, as Heather mentioned, you can reach out to her on Twitter or her email. But also, we have the Trailblazer community. So if you go to trailblazers.community. Or I think it's
trailblazercommunity.salesforce.com.
Right, that's it. Or success.salesforce.com. We'll be able to answer your questions there. But again, thank you so much for joining us today. And if you have any feedback for us, stick around for the survey at the end. Thanks, everyone. Thank you, Heather.
Thank you, Nisha.